So first thing about this problem is that it involves cosecant, and cosecant's not very friendly to work with. So I'm going to go ahead and begin by changing this to the reciprocal, which is sine. So I'm going to say that the sine of theta happens to be 1 over negative 3.245. Now I realize that I'm needing to find the specific value of theta, which means we're going to have to do an inverse. So I'm going to go ahead and set up the inverse, that theta is going to be the sine inverse of 1 over negative 3.245. And whenever I'm doing these inverses, I need to determine what quadrant we're working in. So here we're dealing with sine being negative. So I think about all students take calculus, and sine is negative in 3 and 4. That is where sine is negative. So I have to have a quadrant 3 answer, and I have to have a quadrant 4 answer. When I do the inverse on my calculator, it gives us this negative 0.31326. And a negative on an angle means that we're going backwards. It means that we're going backwards. So if we're going backwards, that's going to put us over here into quadrant 4, negative 0.31326, back into quadrant 4. But according to the directions, the answer has to be in the interval 0 to 2 pi. So what we can do to get the proper interval is to find the coterminal. We find a coterminal by adding 2 pi. So we say 2 pi plus, let's see if I can slide this over, 2 pi plus the negative 0.31326, and that's going to give me a theta value of 5.96991. So that's going to be our quadrant 4 answer. But we also need a quadrant 3 answer. So keep in mind that one thing we're talking about with these angles is if they have the same ratio, then they have to have the same reference. And the reference is just the space between the horizontal and our angle line. So this one right here has a space of 0.31326. That's the space. The negative just meant direction. So this right here has to have the space of the same 0.31326. But now I'm in quadrant 3, and reference is measured from 0 all the way over. So what this is going to tell us is that our quadrant 3 answer is going to be pi plus the 0.31326, whatever that works out to be. That's going to be our quadrant 3 answer. Let me go ahead and work it out. Theta is going to equal 3.45485. Now do keep in mind that you can check all of these answers. So if I simply take the two answers I came up with and go back and just do the sine of the 5.96991 and the sine of the 3.45485, when I do this on my calculator, this should give me back this 1 over negative 3.245. So you can check all of this work. So this next question talks about a bicycle wheel that has a diameter of 40 inches, and there are two pieces of dirt attached to the wheel so that the angle between them is 285. So what I'm going to do here is I'm going to start off by just drawing a circle to represent the bicycle wheel. If I can draw the circle. Alright, so I'm going to draw a circle. And we've got two pieces of dirt that are on this circle. So I'm going to draw a piece of dirt here and a piece of dirt, let's say down here. We're told they're 285 degrees apart. So I'll draw one right here and I'll draw the other one right here so that this looks like my 285 degrees. That would be the origin. Come on down. We know that the diameter is 40, which means that the radius here is 20 in both cases. And what we're asked to do is to find the measure of the arc between those two pieces. So we're literally looking for this arc, that 285 degree arc. since from here to here is 285. So we have a formula for arc length, and that formula is that S equals R theta. And theta has to be in radians. That's what has to happen. Theta has to be in radians. So I'm going to go ahead and put my 285 degrees here. And to change this to radians, I'm multiplying by pi over 185 degrees. This is going to allow my degrees to cancel. Well, to use this formula, we also have to put in the radius. And the radius here is 20 for this particular example. And the S on the other side is arc length. That's that symbol for arc length. So now it's just a matter of crunching it all out. So when I crunch it all out, S is going to equal, it's going to give me a length of 96.79501, and the units will be inches because that's the units on the radius, will be inches. Sorry for the messy writing here. The other part of this question asks you for perimeter. Remember that perimeter means the total shape, and we had a few of these as well. So in this case, the perimeter is going to be, let's see. Let's do a little lightsaber here. The perimeter is going to be the entire arc plus the radius plus the radius. It's basically the idea of a pizza slice. So that entire arc we just have calculated to be the 96.795. We'll have here a 20 and a 20. So adding all of those together, let me just go ahead and add the 96 with the decimals plus 20 is giving me a total arc, or a total perimeter, of 136.79501. Alright, for this question, you and a friend are flying kites near a cliff, and somehow you manage to drop your kite off the cliff into the lake below. You know that 225 feet of string are used between your hand and the kite. And that's important. That's the string length, your hand and the kite. Your friend, who happens to be the surveyor, tells you that the angle of depression from your position on the cliff to the kite is 35 degrees. How tall is the cliff where you and your friend are standing? So here you are standing on top of this cliff, and you've been flying a kite. And the kite falls down and lands in the water. And the string is going from your hand down to the kite. You know that there are 225 feet of string, and you know the angle of depression is 35. Angle of depression is by definition from the horizontal down. So this is where that 35 degrees is, horizontal down. So when we look at it, we actually have in here a beautiful little right triangle. There's a right triangle. This is 35 degrees, and that's the 225. And you're looking for the height of the cliff. So there's the cliff, or the height of the cliff, or over here, the height of the cliff. So I'm just going to go ahead and set up a sine. So sine is going to be the opposite, or sine of 35 degrees is going to be the opposite over 225 feet. So 225 times the sine of 35 degrees is going to be h. So I'm just going to crunch that out. But what I have to do is remember that my calculator is in radians. So we have to input that degree symbol by going to the second angle menu in order to do this problem. So I have sine of 35 times 225 gives me a height of 129.05469 feet.